Okay, good morning. Today we're going to introduce the laws of logarithms. And logarithms, if you remember, are basically exponents. And so the laws of logarithms, those laws follow very much the exponent rules. For example, if you were going to multiply exponents, you'd have x squared, say, plus or times, x cubed. The answer would be x to the fifth, or x to the 2 plus 3. So you add your exponents. Now, if you think of a logarithm as an exponent, these rules make a little more sense. When you have log base b of a product m times n, that's the same as log base b of m plus log base b of n. Let me just write an example. If you have log base b of 3x, you could expand that to be, that would be the same as log base b of 3 plus log base b of x. Okay? And also, when we divided bases with exponents, we subtracted the exponents. So when we divide logarithms, we can expand that expression and they would subtract from one another. So if I have log base b, well, write it like I'm supposed to. Okay, if I have log base b of 3 over x, that's the same as log base b of 3 minus log base b of x. When we had raised a power to a power, we multiplied our exponents. So you can bring, when you have the log of a number raised to a power, you can bring that power in front, that exponent in front, and multiply it by the logarithm of the number. So, for example, instead of log base b, I'll say log base 2. It really could be any number. Log base 2 of 10 to the third power. You would bring the exponent in front. That's the same as 3 times log base 2 of 10. And so we're not getting any answers with this section. That's what I want you to understand. We're only getting the expansion of a logarithmic expression. We're taking a single log expression and expanding it as much as we can. So let's work a few examples. I'm going to move this paper down. Okay, go over here. Alright, and here's some examples. We're going to, if you notice, the instructions are to expand the expressions. Okay, so log base 2 in this case, so that stays the same. We have log base 2, and that is 5 times a times b. 5ab is 5 times a times b. So it's log base 2 of 5 plus log base 2 of a plus log base 2 of b. And that has been expanded so that each of these represents only one part of that monomial that we're trying to take the logarithm of. Looking at number 2, we've got a quotient. So again, this was the first one was the first rule. This is the second rule. So we're dividing, so we're going to subtract. We have log base 5 of 8 minus log base 5 of x. Number 3, we've got products. 6 times x squared times y cubed. 2 of those things that are multiplied together have exponents on them. So first we can expand it. Log base 2 of 6 plus log base 2 of x squared plus log base 2 of y squared, and that gets the sum of those. That's the sum of the logarithms is the same as they are when they're multiplied as one logarithm. But now we're going to pull these exponents out in front because of the rule 3 that we're going by. So we have log base 2 of 6 plus 2 log base 2 of x plus 3 times log base 2 of y. I'm sitting here laughing because my cat's attacking my dog right at the moment. Okay, now we're going to go on to example 4. This we have a product in the numerator, a product in the denominator, but we have a division problem as well. So first let's just separate the numerator and denominator. The numerator would look like this. Log base 3 of 4a squared minus log base 3 of bc squared. That takes care of the division problem. Now we're going to need to expand each of these things. So that's going to be log base 3 of 4 plus, and bring the 2 in front, so it's 2 log base 3 of a minus log base 3 of b, and it's a product, so it's plus log base 3 of c squared. Now what you notice, I should tell you what I should do. I should erase this. Okay. This 2 should come in front, so it should be 2 log base 3 of c. Now I'm almost through. This minus right here is going to distribute across this set of parentheses so that everything in the denominator is going to end up with a subtraction sign in front of it. So I'm going to go over here. I'm going to move up here and write it because I'm out of room. And so this number 4 would fully expand as log base 3 of 4 plus 2 log base 3 of a minus log base 3 of b plus 2 log base 3 of c. That plus was wrong because I needed to distribute the minus sign, so I need to erase that plus, and it is a minus 2 log base 3 of c. Okay. So I'm getting myself confused here. Let's move on. Now we're going to do, this is a little harder problem right here. You notice there's no base written. And so when there's no base written, that's the common logarithm, and it has to be a base 10. And that's what your calculator will do. So your calculator operates in base 10 and only base 10. Okay, we're going to learn the change of base formula on the next page, but for right now, the logarithm is only operates in base 10. So if you remember, the square root is to the 1/2 power, so we can rewrite this as log of a to the 5th over b, all raised to the 1/2 power, because we're taking the square root of all of that. Now, the exponent we can pull out in front, so we have 1/2 log of a to the 5th over b, and then when we expand that, we can have 1/2 times 5 times log A minus log B. And the 1/2 has to be multiplied by all of that, because all of that was raised to the half power. Alright, in this next section, and I'm going to go ahead and pull this up, we're going to go the other direction. We're going to condense the logarithms, or compress them. Okay, so I'm going to move this up. We've got several examples here. We're going to go back from more than one log to just one log expression. This is an addition, so that means that they must have been multiplied. So this is going to end up being log base 5 of 7x when we put it back together as one log. Minus sign means it must have been a division. So this is going to go back together as log base 2 of x over 3. Here, this 1/2 must be a power that goes on the m, and this 3 must be a power that goes on the n. The minus indicates division. So we're going to write log base 6. We've got a division problem. In the numerator, it's going to be m to the 1/2 power, and in the denominator, it's n cubed. Now, the 1/2 power is a square root, so we could rewrite that as log base 6 of the square root of m over n cubed. Okay. Looking at number 9, we've got 3 out here, but that must be a power over this whole problem because all of that's in parentheses, and the minus means we've got a division problem. So we've got log base of 2, and it's a over b, parentheses, all of that has to be raised to the 3rd power. Okay, so that's condensing or compressing back into one log. The last piece, there's one last problem here, and then we've got the change of base formula that we'll look at. This last expression right here, we have a multiplication and we have division. We have some exponents in front, so that comes together as log base 3 of 4m cubed over n squared. Okay, the plus means we multiplied, so there's your 4. This is the cube that goes on the m. Your division, n squared. Okay. Now, in the change of base formula, since your calculator will only do base 10, this is a really handy formula that you need to get memorized. If you notice in this first problem, okay, so this changes, the thing you want to change it to is base 10, because base 10 is what your calculator will do. So our b, for all practical purposes, is always going to be base 10. So look at your original, look at this formula, and then look at this problem. A is going to be, in this case, 2, and x is going to be 25. And now let's put it in the formula as it's written, and we don't have to write base 10, because remember, when you have base 10, you just write log. So to get an actual answer for this, you'd say log of 25 over log 2. Now you need to make sure you can punch this in your calculator and get it. Okay, you'll have to close some parentheses here in your calculator, and your answer should come out to be 4.644. So you need to try that, and if you can't get it, then you need to come in and see me so I can show you how to get to that answer. Again, this number goes in the numerator, so to get an actual answer, you'll say log of 12 over log of 5. And I want to see that written out when you do the problem. Don't just punch it in and give me an answer. 1.544. And on this one you'll have log of 5 over log of 0.5. And that should come out to be negative 2.322. Now I can have a negative answer here, but when I pull up this other example, I want you to notice something. And this one more example is all we've got. When I pull up this very last example, you have log base 2 of negative 4. Now if you punch that in your calculator, you would have log of negative 4 over log of 2. And you would get something, an error message or something that said maybe no real solution. Okay? The reason for that is, remember, you can't take the log of a negative number. Okay? So, remember that when if you see this or if you get an error message, go back and think, oh, am I trying to take the log of a negative number? And no, you can't do that. Okay, so that's the end of our first lesson for Thursday, and we'll go on and I'll make this into a video, and then I'll go on to 2.2 with another video.